Hi guys, and welcome to the show, I would say. So today I'm gonna share some experience about using computer vision for testing navigation systems. And let's start with it. I'm gonna show you the challenges that we meet when test our application navigation actually. The obvious solution we select and problem with it. So then we switch to computer vision and build a small tool, and we use it 3 years actually. We use it for different platforms, different map updates as a navigation system. So we learn some lessons. We have some experience in using computer vision, and we rebuild it with that knowledge. And I will show you some pros and the advantages of using that. So let's start. My name is Dmytro. I work for Intellis, have experience in desktop, web, and embedded mobile automation. Now I automate in Python and Ruby, but I have some experience in Kotlin, JavaScript as well. So I like the navigation, automotive technology. So I use computer vision to do it more intelligent, let's say. Okay, so I have some article on DOUA, so you can translate it or grab it. The most information from today speech, today presentation covered in these articles, but today there is focus for technical part. Here I want to show some practical, some experience based. So how do we test application today? Actually, for most of all application, we have some visualizer or some markup viewer, and almost all elements in UI that, for example, is Google Maps with some tools, some configuration. We have nice markup in XML, HTML with ID, with some, if it's checkbox, we have a lot of information about check it, select it, so on. But if we're talking about map, it actually, in most situation, it's one rendered object that actually have a lot of information. For example, point of interest, some roads, road links, some names of road, but it rendered and no information about it in our markup. So it's like picture. So what to do with that picture? We can compare this screenshot. We can just compare, for example, some colors. But to do it more intelligent, we need some tools. And for example, computer vision can help us to find what we need and actually bugs or something like that. So how we do that? Actually, we provide some navigation system, and each navigation system has a lot of elements. For example, it's road links, so names, some current car position, some tools to check box, to select menu, to change the zoom. And to test it, we need some tools, for example, because all of this element mostly is not present in our markup. So we select, for example, screenshot comparison tool. It's a lot of that, and we use phash for start. It's open source library. It works pretty clear. So you have etalon image, I would say. You have some image with some information, and then the algorithm compares the image and suggests the threshold to use to understand it's equal image or not. So we have some equal image, we have some real images to compare, and if we have small distance, for example, Hamming distance from p hash, we have smaller value than threshold, so we can use that for understand it's the same image or not. We use it in our application. Sorry for that black rectangle. It's in the NDA and I'll connect it with that. But it's part of our application. We crop some images for interest and compare it with different situations. So we have some road name here with some direction, and with different version of map, with different situation, we have some Hamming distance. The biggest value is 17. So if we put this threshold, for example, 20, we say that, okay, everything that smaller than 20 accept for us. But there is different situation, for example, zoom-in test, and there we have some bigger value than 20. Yeah. So here we have some errors, some mistake. It's called first type of error when actually there is no bug. So we there, we on the road, but system say test failed. To break this situation, we just resave more images and compare it in the sequence. So if we have some error, we choose another images selected, and okay, we have some nice situation. If error, we check it again, no error. So we avoid this first type of mistakes, and we go next. And this situation is different. So we have totally different places, but sometimes we have smaller version we have smaller value than our threshold. It's 18, but totally different place. It's a second type of error when actually error there, bug there, there is different place, but in our situation the fail pass. So we need solve some situation. And actually we choose the computer vision and actually OpenCV library. There is a kind of multi-tool knife because there's a lot of functionality about tracking, defining, segmentation, but we don't need all that. In 90% of cases, we use template matching. Template matching work pretty easy. You just have some template. It's part of our images, and there is a function in library that just go with every pixel of original image with that template, and it builds some map when lighter point of our map is defined the place where this template actually located. So we can use another function to locate minimum and maximum and find lighter place and say, okay, there is actually this place where picture is. So there is a lot of method here to find lighter point, to find the darkest point. It's actually work better for different situations, for different images. But the most interesting thing here it's normed coefficient. So we have the lighter point, 100% match, it's 1. So here we can choose our threshold and see, for example, if our button has 80%, 70%, we can choose that threshold and select the point that bigger than our threshold. So it allow us to use multiple template matching. So there is example from Stack Overflow actually. So there is just threshold 0.8, and we just template matching and locate only elements that above our threshold. So we find it, just draw this rectangle and go with places that we need. So we're happy with that, and we try to implement it in our testing, in our navigation testing actually. There is easy example with Google Maps. So we get some location, for example, it's office of our company. We get template from that. We just crop it, images, and then we try to test it in another location of our offices. So it's Krylivska 39, it's 15, and we have match. So there is fails that we meet because Google Maps has this pink style. We have gray style, for example, and everything match because the algorithms say it's almost the same. It's not interested in this building, you see, not interested in this location. So we have the map, we have really light point of matching. So threshold is 0.8 and we have value of 0.85. So it's something wrong with that. And there is another 10% that we need to use, and the template matching, it's not good actually for map matching. So what else in OpenCV library? There is a lot of things, but one of the most interesting part is feature detection and description. To understand that, we need to remind how we play with puzzle game. So there is a lot of puzzles, and we need to put it on our images. So to easy place when we put this cropped images is actually with corners, because the corners, it's one place in the images when we can put it. For example, this E and F parts, it's located only here and here. So you can put it on the sky or on the wall, but this C, D, B, A, you can put it a lot of on the sky, for example. You can put this a lot of on the wall. So there is no unique information in that object. This is A and B part. It's called flat object because you can move it up and down, left and right, and no difference with that. There is C and D. It's edge because yeah, it is part of the roof, but you can move it left and right, and no difference. If you move it up and down, you see that it changed, but left and right now. So to work with that map, to work with that feature finding, we need to find some corners. How to find corners? We need a corner detector. It worked actually easy. It started working from Harris actually. So there is simple way, just move this part up and down, left and right, and see how difference of the characteristic. So this part, if it move left and right and no changes up and down, it's kind of flat region or edge object. But if you move this part and characteristic is changed significant, so it's corners that it's interesting for us. So there is some examples, some method function in Python that you have only your image, you have block size, case size, so it's the default characteristic, and you have located these corners on your image that you're interested. So what do next? Next, it's need to calculate this characteristic of these corners, and it works like you drop all your corner part or your cropped corner to this descriptors, and you find the direction when your light of your this small rectangle move from dark side to light side. In this picture, it shows that there is car, there is kind of part, and here is more darker place, and this corner is more lighter place. So the vector of direction it's up and right, and for each for each part of our corner, we just build this map. It works good for color images, for grayscale images, but it's better, it's faster in grayscale. So there is actually a method in Python. So you just detect and compute all these corners and have this direction, some characteristic of that. So how to match this feature? Actually, for example, we have some one picture, some another pictures are actually imagine this the same object but in different condition. For example, rotated, some lighter, higher, for example. And this is most interesting thing because there is a lot of way to calculate the difference, but the most interesting is cross-check and ratio test. What's the difference? The cross-check, and when you have there is first triangle, it's one picture. Second triangle, it's picture with some difference, the same points. And you calculate in cross-check difference for each point of one picture, difference to each point of second picture. You see that difference 3, 7, 8 difference. The less difference, the close the points. So if no difference is the same point actually. So we calculate difference for first images each point to each point of second images, and then we calculate for second images difference for each point of first images, and we select the point if it has equal difference, smallest difference for bidirectional comparison. For example, this is A button, and it has difference 3, 7, and 8 for each point of second images. Okay, the smallest value is 3. Okay, go there. But for this point, the smaller value is 2. So this match is fail because for this point better that, but for that point better that. So go there. For point C, we see that 2, 7, and 1. Okay, so 1 is better, and for C, from this point, 1 is better too. So only this point pass this cross check. So the images should be really the same, so it has no error, so no mess in that to pass cross check. And sometimes it's not work. So the better work is ratio test. Ratio test, it's about some summary that if point from one picture a second picture it's really the same, the difference between that points should be significant better than others. So there is only one direction of comparison from first images to second images, and if this difference significant better than other, it should accept this point. Significant better, for example, better twice or 75% than other. For example, this difference 3, 7, and 8. So 3 it's much better than 7 and 8. So the point A is accepted. Or for example, C, we have 1, 2, and 7. 1 it's twice better than 2. It's smaller than 2. So we accept this point. And if we're talking about 4, 5, and 6, actually 4 it's not better than 5, so we reject it. How it works in Python, in OpenCV library, there is the method brute force matcher. You create the object, you just select the ratio, the rate, and you select, for example, percentage, we use 75%. If it's better for 75%, it's okay. So there is all about theory of using, and let's use it for testing, for example. First of all, it's we build some scripts to match template, for example, and we find that if we, for example, select our threshold 80%, a lot of point pass this threshold. So if we have template for Google Maps icon and we find it in our screen, we have accepted all this value from 90%, 95%, 100%, and how to understand how many template we find, because we sometimes find 100 templates matching, but we know that only one icon template for Google Maps there. So we use parsing point. We just accept some radius, and if all this point that found located in this radius, we call it cloud of points, we accept that it's the same point. So we choose the radius at half of smaller part of our template. If our template have 200 pixels width and height, we use half of that, so radius at 100. And if all the point in this big radius, we assume that it's the same point cloud, the same template. The second part is zooming, because sometimes the images has changing. We have new maps. So for example, for Chicago, we have bigger some place, we have bigger some building, and we implement this feature of zooming. So if first template matching fail, we have scale, we increase this part, and then if we have fail even with 150%, we downscale it and see some result. It's really help us. It's really help to testing. So the first script we implement, it find template on images. It's obvious, and here is some notation and how to use that. It's simple script for running. We just parameterize with template it's small images, image with big images, and the ratio to use it. For example, from 0.01 to 100%. It's and default it's 0.6 is a good value to start with. So actually we can flag with downscale, upscale to see what happens. So how it works, it's template image, just find template on image, build the map, and select the matching. Here we see that accepted values, there is a lot of, because template is 0.65, and all values that bigger than, and even 100% accepted. But then we sparse the point and have only one clouds. So clouds with radius, and we have coordinate of that. The second script, it's a script for finding objects. It's almost the same. You have some train images like templates, for example, and query images like template. It's a small part of the big images you find on. And of course, you can use downscale, upscale to select it. So there is the same example about some query images, train images, and results. So you have some clouds that accepted point, that's 63 points that accepted, but then it combined it in one cloud, and then you have
some information about matching, about the corners. So it's find 17 corners, 11 good match, and common it's 10. What is common? It's have connection to coordinates. So here we see some matching here from this part of images and second. And we accept this situation when if point matched, it should have similar coordinate for that. So we fail this matching and accept only those who have similar coordinates. So we have 10 common points, and we accept that. There is some negative tests that fail when we use templates. So there is query images for another location, train images, and then we, as you see, we find some similar location, but then we reject this point because we have 17 corners, we have 2 good matches and 2 common. And if we say that from 17 we have only 2, it's actually too small to say it's the same point. So we fail it, and the test is okay. It should be failed. So it's a couple words about our framework. There is kind of a lot of technologies, because we have actually a system based on Android system that run in our cars. So there is OpenCV library run with Python, and then we have wrap all this with a lot of Ruby tests, and we use Cucumber for another reason of that. So you can just throw up some technology and use technologies that you use. For example, it could be Java, it could be another language to JavaScript for automate. But this part of OpenCV and Python, you could use it actually for computer vision, for some image testing. There is some example of using computer vision. We built some example to show that you don't need actually some drivers to see to test markup. You can select images that you actually need to open the application, to press the button menu. There is some old images example. Now Google Maps has some different example, but anyway, you open menu, you find some icon on your phone, then you go to map menu, you select some scheme, you select some traffic, you tree the building, then you push the find, you press this address, and then you find this location. So there is no XPath, no XML selector. It's just map, drive, and test. It actually good work for some charts. There is my steps, for example, and to open that you need the same menu, Google Feed, then go to dashboard, find some place with these bars, and just find bars you need. So we have some bars that accept our goals. Yeah. So there is another test of cardio activity. So if you have some chart that change it for circle to some pentacle to some rectangle, you even use it. So there is templates with corners that you can use to understand you achieve your goals or not, you successfully or not. So it works okay too. Couple of words about how to choose the selectors, how to use it. Actually, you can select what you want, but what works better? Actually, there is a type of map. It's actually a checkbox, and it's selected when it has this border. So you can select this part of border and test it's selected or not. We have a lot of button like this when change the appearance when it's selected. So borders, it's nice to choose template. If we're talking about some borders that we don't interested in it, if we test select button or not, we can use borders. But if we can just push the button, we don't need this border, so we select the template without borders. Actually, the digits or words, some symbols, it's not good because if we have multi-language applications, so there is kind of problems because any fonts, any different language can break it. But if you have one language application, if you're okay with finding text, you can use it. But there is a lot of library in Python to find actually testing images. So it's not the best solution to test text. And actually, if you want to find sequence, it could work too, but sometimes there is another borders, there is another buttons can be, so you need small your threshold to just put 3 on 1, and it's okay. If we're talking about query images, so some part of images to find as object, you should avoid some place that obviously in every image that you use and test. For example, this pointer, this name, this numbers could be in images you find, and it will find your numbers. It will find some locators, but not find your location, your building. So you should actually use what you're interested for. So it's if it's building, it should be the lines of building. If it road, it should be line of road. So avoid the text, avoid the images and the icons. Okay, what we use for testing? There is actually parts of our UI. I would say so. We have compass, we have destination point, we have some plus button, we have some digits. So there is example of part of we're using for testing. So the line of road, the some part of building, the some unique unique architecture. It really nice place to find in display. Actually, there is a couple of tests we automate successfully with that. For example, it's Farry, and if settings allow to go through the Farry, the road should build through the water. And if we don't allow, we use settings so no movement through the water. So if it's selected, if it's displayed, we can test it with computer vision. So if we see that road, that we actually go not by the Farry. If we see that that part of road, we're okay with that. So it's kind of really cool because no way to automate it without some checking on UI. And then actually a high occupancy line, if you know, it's a place on the road when you can go only with passengers. So if we have these settings, we just understand that, okay, you need go to left and it's high occupancy line. And if we see that part, this maneuver, then we use it, then it's successfully. So it's Another example of using just if you see the maneuver, you use this whole line or don't use. So it's tested with this tool. There is another example. It's different. Different type of our application. It's totally different platform, and my colleagues use it successfully too. So they test maneuver. If we see these arrows, you can pick it, and they have a different type of arrows, and test routing with computer vision. The couple of example of fail of using. So here we see some place, but with different version of map. So they're actually changed the roof, the color, and we fail with that because we the different point was found, and no matching with that. So with that situation, we just switch it to that building. But first we use that. Sometimes it's not works good as we expected, but we understand that sometimes it's not work. And actually, this situation when the building was changed, you see that a lot of corners here, but for now it approximated, and it's failed. It's failed, so we switched to this building to get better result. It's not changed. Some numbers about using. So we have smoke regression and map acceptance, and we have this timing. So footy test run 2 hours, 60 test 3 hours, and we have night test for this number. It depends on the logic, because sometimes we went 5 minutes for online traffic. It's not because our framework so slow. It's because functionality sometimes need time to render it. But there is some understanding how fast is that. Actually, the copying, the making screenshot and the pulling, it's about 1 second. It's actually download time too fast. It's 60 milliseconds, but the checking that checking the zoom, the checking correct downloading and copying, sometimes it costs our approximately half second and second. There is for this resolution. Finding templates 50 to 50 pixels. It's cost 3 second max, because if you use 12 zoom levels, we have more time. If we find it with first zoom level, we have the small time, but it's 3 second max. And for object, we have 4 seconds. It's quite long time. You can play with shooters with that, but I think there is possible optimization, but it's okay for us. We don't hurry with that. We use it as it is. So actually, what about advantages and disadvantages? So of course, the computer vision can solve issues that rendered objects that can solve, for example, simple screenshot matching. Actually, it's easy to prepare data. It's just make screenshot, crop it, check it, and if you're okay, you just put it to your framework. There is no need to some model training, some artificial intelligence, because it works as it is. And it could be used for find elements, all elements on the screen, markup or not, to test it. Of course, it's some long time to testing. You can play with game with it, and it is not object detector. You can find maneuvers, cars, people, because you need training for that. If you have maneuver only in one direction without rotation, you're okay with that. But if you crew, if you have some rotation, you have really trouble. About summary, you can use template matching for icons, charts, buttons. It's good with that. It's 90% of test cases. And to find the object on the map, on the real photos, you can use object findings. So never know what new feature brings. So sometimes you can go with the template. You can go with markup finding, with XPath, with CSS selectors, but sometimes you need some unique solution.